Okay, good morning, everybody. How are you? Looks great. So welcome to the Infectious Disease Epidemiology course. So I'm a course director, Masahiro Kihara, a professor of the Department of Global Health and Socio-Epidemiology, and I'm chief advisor to the UNAIDS Collaborating Center for Socio-Epidemiological HIV Research located in my department since the year of 2006. With assistant professor Masako Kihara being the director. So we are very pleased to have so many students for our course, so it's enthusiastic to learn, hopefully. Okay, so let me take introduce briefly about timeline of our course. So this course starts with a lecture by Dr. Teeranee, Techasrivichien, who is a graduate and assistant professor of our department. And he's going to introduce infectious disease and human history, introducing how they interact, how we interact with each other from the past to the present. So next, Dr. Pina Sugimoto, who is also a graduate of our department, and now the lecturer of the Center for Medical Education of the School of Medicine, is going to introduce the current status of global infectious disease epidemiology, showing you the so-called emerging and re-emerging infectious diseases. So next, I'm going to talk about the global HIV epidemic to show you how the epidemic of infectious diseases is embedded in the social, economic, and cultural context of the community or society, taking HIV and AIDS as a typical example. So next, Dr. Musmari Patomasika, he is also a graduate and assistant professor of our department, going to introduce a very basic theoretical concept of infectious disease epidemiology, introducing you some mathematical modeling of the disease. Because infectious disease transmit from man to man or animal to man, so this process can be modeled using the mathematical formula. So we're going to introduce very basic concept of it. So then we are inviting Dr. Takaaki Oyama from the National Institute of Public Health in Tokyo. He's talking about field epidemiology. He's the most experienced field epidemiologist in Japan, responsible for the national training course for field epidemiology for over 20 years. I'm sure you will enjoy it. He's going to take 2 classes. And finally, we are inviting Dr. Shinako Inaida, who is assistant professor of the Department of Pharmacoepidemiology of our School of Public Health, who used to work in the National Institute of Infectious Diseases in Tokyo. So he's going to introduce the national strategy of infectious disease in Japan. So not shown in this slide, but we have one more class between myself and Dr. Musumari. So inviting the 2 AIDS patients who are getting infected with HIV through contaminated blood products. In other words, they are victims of the so-called HIV-tainted blood scandal, in Japanese, yakugai AIDS. So because they are going to talk in Japanese, also with their personal history, so to protect their privacy, we did not include in this slide. You will understand. Okay, now, so I would like to pass this microphone on to Dr. Teeranee Techasrivichien. We shortly call her Ja. So please, Dr. Ja.
Thank you, Professor Kira, for the introduction. And I would like to start off introducing the agents which cause infectious diseases. They are largely categorized into 6 groups. The first one, the virus, for example, the well-known HIV, and bacteria such as the E. coli, the virulent strain can cause bloody diarrhea. And there's also fungi such as pneumocystic gyrovecti, the cause of pneumocystic pneumonia, helminths or the hookworms, and protozoa such as Plasmodium falciparum, the cause of malaria. The last category is the prion, which was recently coined in 1982, that causes transmissible neurodegenerative diseases such as Creutzfeldt-Jakob. So as we can see from the slide, the knowledge of infectious diseases, modes of transmission, diagnosis, prevention and treatment are all very clear to us due to discovery of microbiology and also technological advancement. But have you thought about a few centuries ago when science was not yet well understood? How did mankind handle or deal with diseases? How did mankind understand what were the causes of diseases in the past? So let's go through that throughout this lecture together. Of the infectious disease and human history, as Professor Kihara has introduced, my name is Teeranee, and I am now the Assistant Professor at the Department of Global Health and Socio-Epidemiology at Kyoto University School of Public Health. It is now very close to Gion Matsuri already, and we thought this might be interesting to introduce into the class of infectious disease. The Matsuri, or in English, is known as a festival. It is celebrated annually in Kyoto in July. And not only in Kyoto, Gion Matsuri is famous, among one of the most famous festivals throughout Japan. And it is a very good example of how infectious diseases are weaved into the human history. So what is Gion Festival all about? Kyoto has suffered from many occasions of all kinds of bad omens, including epidemic and natural disasters, such as flood, fire, or earthquakes. So the festival originated approximately 1,100 years ago as a part of purification ritual to appease the gods that were thought to be causing these disasters and epidemics. So as shown in the photo here, maybe you can notice that these are the festival floats, and they have very high pole. In ancient time, it was believed that actually this pole can help clean or filter the air and catch evil substances that was floating around the air. The floats will also be paraded throughout the town so that these tall poles can maybe clean up the whole town, catching the evil substances in the air. Also, the timing of Gion Festival, the fact that it's typically held in mid-July, just right before the summer. Also for people to pray to stop the annual peak of diarrhea and dysentery. I personally took this photo from Yasaka Shrine, and maybe some of you know the shrine for international students. Yasaka Shrine is one of the most famous shrines in Kyoto. And there's this charm called Chimaki. And they are very specific to Kyoto, very specific also to only available during the Gion Matsuri. And so what is chimaki? From the records, the origin of chimaki is believed to have been a thatch ring that were carried on the waist by Somin Shorai and his descendants. Somin Shorai was a poor man, but one night he warmly welcomed a traveler into his household when this random traveler needed a place to stay for the night. Without knowing that this traveler was actually, in fact, one of the Japanese primary god named Susanoo no Mikoto. And even though Somin Shorai was very poor, he provided to this traveler the best what he could, maybe a bowl of rice, so on and so forth. So in return for this generous act of a poor man, when the god was departing, leaving the house, he presented chimaki to Somin Shorai. And the god promised him that Somin Shorai and his descendants will forever be protected from diseases and bad omen forever. So the tradition is carried on until today, and holder of chimaki are considered to be the descendants of Somin Shorai. And I also took this photo on the street of Kyoto. If you can see here, chimaki are placed in front of the entrance door with the belief that it can protect that particular household from fire or diseases. Also, this is the great Buddha at Todaiji in Nara Prefecture. During the year 729 to 749, Japan suffered from a series of disaster and epidemics. And to prevent those from happening, Emperor at that time, Emperor Shomu, issued an official order to promote the construction of provincial temples throughout the nation. And Todaiji was built as a provincial temple of the present-day Nara Prefecture, and it was also promoted to be the head of all provincial temples throughout Japan, so that people can pray for the prevention of epidemics and disaster. So as we can see here from both example of Gion Matsuri and Todaiji, we could see that illnesses were believed and considered to be the curse from angry spirits or from other supernatural powers. So for the session, we will talk about the infectious diseases and their historical course since maybe over 10,000 years ago from the hunting and fishing age. And then followed by the period of stock farming, agriculture approximately 10,000 years ago, and subsequent European medieval period from loosely from 5th to mid-15th century, and the Great Age of Discovery from 15th to maybe mid-17th century, and the Age of Enlightenment and modern times from the 18th century onwards to the present day of approximately 20th century onwards. So for almost the whole of human history, mankind has lived by carrying out these two basic activities of hunting or fishing and gathering edible items as hunter and gatherers. Also, they lived in small groups and they travel constantly to hunt and forage for food. Source of infection was probably from the nature, maybe from insects, animal, water, soil, so on and so forth, but not from human to human. There was probably infectious diseases, but such isolation of a small group of people would have caused the epidemic to be restricted to any given local population. So the propagation of the epidemic was difficult since the population density was low during that time. And since humans lived in small group and traveled constantly, frequently, they had fewer problems with accumulated waste and contaminated water sources or food. And the change comes approximately 10,000 years ago. Humans started larger and larger communal existence and forming a concentrated community, learning skills to cultivate crops and domesticating animals for a more varied and secure, reliable food sources, and also maybe tool development. These overcrowded communities that evolved after the agricultural revolution often had inadequate means of disposing of garbage and also sewage, which tended to accumulate. And also rodents, insects and fungi were attracted to human settlements due to the accumulated waste, and they provided means for disease propagation. Also, overall, altogether of these accelerated the growth of the vectors. Waste were also contaminated into water sources, and the usage of pond and adoption of water reservoir cultured the life cycle of mosquito and parasites. Farm life and livestock also brought human into close and constant contact with animals, and likely leading to the first zoonosis, which is a cross-infection between animals and humans. This probably marked the first major step in infectious disease in human history. Okay. And these more densely populated, complex social groupings were believed to be contributing to the emergence and the spread, the origin of epidemic of infectious diseases. So when human had agricultural products, or maybe animals or tools, they started to have trade. So that also marked the expansion of the epidemic of infectious diseases. So in terms of what were the causes of infectious disease, what did people understand? The determinants of diseases. As we could see from the example of maybe Gion Matsuri and Todaichi in the previous slides, diseases were considered and associated as with supernatural powers by religious and myth beliefs. But Hippocrates was the first to propose the relationship of diseases to environment. He was the first to look at diseases not as punishment from gods, but as an imbalance of man with the environment. He related diseases to individuals' exposures. He wrote about the spread of diseases by means of airs, water, and places. Okay. And he made the association between climate, diet, and maybe living conditions. he observed that different diseases occurred in different locations, and that malaria and yellow fever commonly occurred in swampy areas. So with his influential theory, it was for many years a commonly held belief that illness was a result of imbalance in body's humors and due to poisonous vapors or the miasma. And maybe this would be interesting to you, that a killer disease like malaria and is suspected to have the evidence of suspected miasmic origins. So malaria is derived from Italian, mal meaning bad, and area is air. So the disease itself has the concept of bad air in its name. Although this was unsophisticated by today's standard, it was the first major step forward for the scientific community, so that to consider the diseases in relation to environment, but not due to superstition powers. So we now move to the medieval period. During the time of the medieval period, roughly from 5th to 15th century, humans were living in a more congested city with poor living conditions, and this resulted in large scales of a series of outbreaks of infections. Some examples are Hansen diseases or leprosy, measles, smallpox, and plague. The first well-documented plague was in the 6th century. It was estimated to kill up to 10,000 people according to historical records. However, the most devastating and deadliest during those times was the so-called Black Death of the 14th century. So the figure here shows the spread of bubonic plague or the Black Death in Europe from 1347 to 1351. Records show that Black Death came to Europe on trading ships that sailed from Central Asia. This ship has sick passengers and dead people on board. They docked into lower parts of seaports of Europe, and then within the next 5 years, Black Death rapidly spread throughout the entire Europe. It is estimated that Black Death wiped out 50 to 60% of Europeans' total population, and roughly 60 million of the world's population. To kind of demonstrate how severe it is, maybe 60 million now is roughly equal to half of Japan, half of today's Japan. So this severe spread of the Great Plague has led into the first organized institutional responses to disease control. At that time, there were no effective measures, no effective treatment against plague available. And among other speculations, the prevention was to avoid contact from infected person or contaminated objects. And as a result, officials were taking measures to prohibit entries of ships. In 1374, in Venice port, they took the first prohibition measure to deny entry of ships with infected persons. And then a few years later, in 1377, the Dubrovnik seaport in Croatia started to retrain travelers for 30 days, but later they lengthened to 40 days. And in Italian, maybe my pronunciation wouldn't be too nice, it's quarantina, which gave birth to the term quarantine, and also the concept of incubation period. And this is to show you how the port looks like. This is the present day port of Dubrovnik in Croatia. Maybe as you can see here in these isolated stations, there were quarantine station that maybe asking the ship to being halt for a few days during the past. So the cause of plague was not known, not well understood at all. But there were many theories, and the most popular explanation was that it was caused by miasma, as we previously discussed in the previous slides. Miasma are invisible vapors, poisonous vapors from the swamps that floated around in the air. Others also thought that plague was spread by person to person. Hence the previous slide we saw the measures of quarantine. Also other theories included intentional poisoning. In the following slide I will be explaining a bit more. However, the miasma theory was the most popular. And the photo here shows the outfit of the plague doctor, and with a special mask, if you can see. So the beak-like portion of the mask is filled with aromatic herbs, in believing that they will help filter the poisonous vapors or the miasma. And since science was not well understood by then, other theories of the causes of plague were also due to witchcraft and intentional poisoning. The photo here shows the Black Death persecutions that were a series of violent attacks on the Jewish communities that were blamed for the outbreak of Black Death in Europe during those 1340s and so on and so forth. So accusations spread that Jews were deliberately causing the disease by poisoning the wells. Jews were suspected because they had lower mortality rates as compared to the rest of the Europe. Why? Because due to mainly two major factors. First, because of their better hygiene rituals. They have these religious rituals of daily cleansing and washings. And in addition to that, the second reason may be that they are often walled off in a mandatory ghettos in a separate section of the town, in which that would naturally limit their exposure to the infections. Also here the photo shows the incineration of personal belongings of plague-infected persons, which is the other measures against plague, were to burn personal belongings. Bonfire and smoking urns were believed to prevent the miasmatic plague, also during those time of plague outbreak. Leprosy was another major public health in Europe during the medieval time. And since science was not well understood at that time, leprosy afflicted persons were feared and misunderstood, and they were treated with discrimination. Lepers were stricken from the society as if disease was a sin. They had to wear special clothing, if you could see, and to carry with them all the time this bell to be able to warn the others that they were coming close. Some even require lepers to stand in a dug grave and to receive this mass of separation, after which they were considered as dead. As stated in this mass of separation, maybe we could go straight to the middle section. I forbid you, if you go on the road and when you meet some person who speaks to you, to fail to put yourself down before you answer. I forbid you to go into a narrow lane so that if you should meet anyone, he might catch the affliction from you. So as implicitly shown in this mass of separation, again, the concept of diseases were majorly being related to miasma theory. Then comes the Great Age of Discovery. This extensive overseas exploration by the Europeans, they were fueled by the growing interest of external physical world, desire for trades, and also new markets, colonization, and slave trades. The Columbian Exchange, or the Grand Exchange, was the widespread transfer of human population, cultures, animal, plants, products, and between the American and the Afro-Eurasian hemisphere in the 15th to 17th centuries. Along with the advancement in astrology, mankind developed technologies to build ships, the stronger ships that could sail further, longer distance, and lighter ships to maybe carry a larger supply of food and necessities during long distance traveling. The most important of all during this Columbian exchange seem to have been the diseases, which is the byproduct of this unintentional exchange. Also, the tropical areas were being explored and giving rise to the epidemic of new diseases. So here are some examples of the exchange of diseases. Syphilis was among the first global diseases. So here's syphilis. In 1493, Columbus' crew brought syphilis back into the old world upon returning from the New World. And the first known epidemic, global epidemic of syphilis, then occurred in Europe in the next few years during the Renaissance in 1495. Also, the other example is the landing of Spanish into the New World, the present-day Central and South America, that has introduced diseases such as smallpox, flu, or typhoid fever, plague, and so on and so forth. That is believed to has wiped out 95% of the population, of the indigenous population, that have led to the downfall of the Inca Aztec, for example. Though it is written that the subsequent infectious diseases outbreak were due to unusual climatic conditions, scientists believe that it was in fact, this first introduction of smallpox that have led to a poor living condition in addition to the wake of the invasion itself. And as we can see here, written in the label, the Mexican population did not recover to prehistoric levels until the 20th centuries. Other examples include the reduced in number of Aborigines in Australia, and when British explorers brought in smallpox in 1788, also when syphilis was introduced into Tahiti. Again, returning to the historical views of the causation of infectious disease, Fracastoro was an Italian physician, a poet and an astronomer, and also a geologist. He was also an important historical from the 16th century. First, for his naming of syphilis that was derived from his famous poem, when he described a legend of a young man, a very handsome young shepherd man named Syphilis, but with the punishment from the god, he was punished with a terrible disease and was suffering syphilis. And secondly, Fracastoro was very famous for his revolutionary theory, the contagion or the seed theory, that infectious diseases were transmitted from person to person by a minute invisible seeds, and that were specific to individual diseases and then were self-replicating and acted on bodily humor to create disease. He proposed 3 modes of transmission of contagious disease. First, by direct contact from person to person through contact with fomites and also through the air. Although very revolutionary at that time, he did not realize that these seeds were actually microbes. Okay? But his theories were respected far ahead of time, and but it would take another 200 years later to prove this theory following the invention of microscope. So up to this point, we have seen through the history from early epidemic how observation of diseases were taking place, and from the work of Hippocrates and Fracastoro. So in modern times, and maybe the age of enlightenment, more discovery and observations have led to intervention and care of the patients. Selected major historical marker in infectious diseases are as listed in this table. For example, discovery of vaccination by Jenner, the observation of epidemic of measles on Faroe Islands by Panam, and measure against childbed fever by Simon Weiss, and the classic cholera epidemic in London by Snow, germ theory by Pasteur, and so on and so forth. One of the greatest contribution to the public health movement was the introduction of effective measure against smallpox towards the end of the 18th century. Smallpox was the primary cause of childhood death, and it was estimated to kill approximately 400,000 annually, with mortality rates of 25 to 40%, as high as 40%. And survivors are often left disfigured and blinded due to the lesions. In 1700s, the West adopted this method of protection against smallpox, but it has been recognized and practiced in ancient China for many centuries. In 1721, Lady Mary Montagu introduced variolation to England. It is the inoculation of material from the true smallpox pustules, which produced a milder attack, than the spontaneous infection, thus giving protection to future attacks of smallpox. But actually, variolation is a dangerous method. So Edward Jenner was interested in finding a better and a safer approach to preventing smallpox. Based on his observation that milkmaids were immune to smallpox because they already had cowpox, he was convinced that cowpox could protect against smallpox. And to stress that these were purely from the observation and they were not based on any scientific study. Okay. So Jenner became convinced and decided to perform the first vaccine clinical trial ever recorded in human history in 1796 by inoculating this 8-year-old James Phillips with the material, the pustules, that was recovered from the hand of the milkmaid who had cowpox. So later, 6 weeks later, he wanted to confirm and to prove whether his experiment was indeed effective. He later injected the actual material of smallpox into the boy 6 weeks later. And he proved that the boy was later immune to smallpox. This experiment gave rise to the birth of science of vaccination, and Jenner also coined the term vaccine from vacca in Latin, which means cow. As we can see, this discovery is incalculable, has incalculable benefit to mankind, and it led to eventually smallpox eradication 180 years later. Another milestone in infectious disease epidemiology was Panem, expanding on the concept of careful observations of individuals. Peter Panem, a Danish physician, at the age of 26, a newly graduated, a very brilliant physician. He was designated by the government to the Faroe Island and to investigate the outbreak of the measles, which has subsided in Faroe for 65 years. So Panem's clinical observation provided the first accurate account of the natural history of measles, that the disease is passed on from person to person. Hence, he denied the belief of the miasma theory. Also, Panem took the advantage of the fact that the island was isolated. So he studied the transmission of the diseases. He observed that the measles rash appeared approximately 14 days after the person is exposed to the infective matter. Thus, he described the concept of incubation period with his observation. Also, the observation that no one of age above 65, if you remember, I mentioned that there was an outbreak 65 years ago. No one of age over 65 developed disease during his observation, and that the attack rate of those aged under 65 was as high as 97%. So he described with his observation that there's an age difference with the attack rate of measles, and also that if you survive this infection, it would provide you a lifelong immunity. So also, as he wrote in his report, proposing the concept of lifelong immunity in his observation. Yet another significant example of observation and intervention. In early 19th century, childbed fever was a common cause of death among women following childbirth, with mortality rates as high as 25%. And many theories of what causes the childbed fever were popular at that time, such as the atmospheric toxin, as we have heard throughout the course, the miasma, or even the solar or magnetic influences. So this period, there was the growing interest in pathologic anatomy. And because the cause of childbed fever remained unknown, great interest was also in findings the answer through performing autopsy in women who died of the diseases. So Simon Weiss is a Hungarian physician who was the pioneer in these sterile surgical practices. As shown in this figure, that shows the mortality rates in the first and the second division of the Department of Obstetrics in Vienna, lying in a hospital between 1839 to 1849. Simon Weiss was appointed to the first division in 1846. The first division had only medical students and physicians, while the second division, as shown in a dotted line, had majorly midwives in their division. So he shows from, after his appointment, from the retrospective records, he showed from the retrospective medical records that it is in fact the hand of the medical students and the physicians that may be carrying the cause of childbed fever, because they went to autopsy room, coming back without washing their hand and assisting delivery to women in the first division. So he performed the first experiment by introducing an intervention. He asked the medical students and the physician to wash their hands and to also brush their nails to remove the dermis before returning to the obstetric ward in the hospital. So subsequently, after this intervention by Simon Weiss, for the first time in 10 years, the mortality rate in the first division was in fact becoming lower than the second division. But unfortunately, due to his liberal way too liberal political views, and the fact that the bacteria was not identified, his theories were not so welcome by the medical professions, and that resulted him in leaving the hospital in 1849. And we can never not talk about this classic example of the epidemic of cholera in London in the 1800s. So the photo here shows the sign posted by the graveyard of the church during the outbreak of cholera in London. At that time, it was the major cause of death in England. And the problem was so severe that the churchyard put up a sign to refuse further burials of those people who have died of cholera. And the table here shows the cholera rates in London during the 1800s. There were four major episodes of cholera outbreak. Approximately 16,500 deaths in 1832 to 33, 14,000 deaths in 1848 and 49, 11,000 deaths in 1853 to 54, and 5,500 deaths in 1866. So to demonstrate the quality of water in London during the 1800s, this is the drawing by a journalist called John Wright, and he named this drawing Dolphin by following the name of this outlet that was pumping water supply to London. So if we can see here, maybe this is not so clear, but this is the actual water source, which is right in front of the sewage described here, the mouth of the Great Common Sewers, number 2. Also, number 3 is the company's steam engine. And as you can see, the pollution is being generated right by the side of the river. Also, it was very close to the drainage of the hospital. So just to show you, during that time, sanitation was not yet well developed in London during 1800s. And as I have previously mentioned, you may have already heard this in other classes. John Snow was a British anesthesiologist. He was famous for administering chloroform for a painless delivery to Queen Victoria. And he was also considered the legendary figure in history of public health and epidemiology for his work in identifying the source of cholera outbreak in London. John Snow examined the neighborhood where there was the ongoing outbreak of cholera to look for the underlying theme that linked these people together. So this is the map of the Broad Street, and he noticed that almost all cases of cholera occurred close to this pump in the middle of the street. And so he concluded that the consumption of water from this pump was the common factor among the patients. So his finding was very compelling, and he could persuade the local council to disable the pump, which later ended the outbreak in the first phase of cholera. But to remind you that germ theory has not yet been developed at that time, and it would take another 20 to 30 years to confirm the theory with the development of microscope and the actual discovery of the microorganism itself. So Snow did not understand the mechanism by which the disease was transmitted, and his conclusion was purely based on his observations, and without the knowledge of the existence of microbes, he demonstrated through this epidemiological study that water was the mean could serve as a vehicle for disease transmission. So his theory made him believed in germ theory as opposed to the miasma theory, competing theory at that time. In the second outbreak of cholera in London a few years later, he again confirmed his assumption that water was actually the mode of transmission of cholera. So initially, two water companies, the Saltwerk and Lambert Company, used the same water source, and initially they had the same death rates among the consumers. But later, due to technical and non-health related reasons, Lambert Company moved upstream of the water source to a less polluted area. So with his observation, this served as a natural experiment where he could see a much more death rate of choleras among consumer of water supply from this company, and that he could prove that water was in fact the main vehicle for cholera transmission. At the same time of cholera outbreak in London, William Farr, who was a statistician and the head of General Register Office of the government department, he was responsible for recording births and death and marriages. His most important contribution to public health was in setting up a system that routinely recorded morbidity and mortality. And he's also considered as the pioneer of medical statistics and demography. So for a while, William Farr was convinced that cholera was transmitted by air. As shown here in this figure, the death rates per 10,000 population and the elevation above the Thames River. So he reasoned that soil at lower elevations, especially near the river banks of the river, contain much organic matter, which produces miasma. So he simulated a calculation based on miasma theory and compared it with the observed mortality, and they produced a very similar result. Coincidentally, to support his belief that cholera was being transmitted by miasma. So as we have gone through throughout the course, it is true that many people have led groundwork in germ theory, but it is actually Pasteur and Koch, which will be introduced in the following slide. That strengthened the germ theory by providing proof in experiments that provide accurate results and findings to support the germ theory. Pasteur proved that the idea of germ theory, and that it was microorganisms that are behind the fermentation of sugar into alcohol and spoiling of milk. Many people at that time believed that living things could arise from non-living things by the action of God in the spontaneous generation theory. So Pasteur was convinced that any growth that appear on maybe food, such as mold, were from microscopic microorganisms that were presented in the air. And he also developed the heat treatment technique called pasteurization, and that could kill microorganisms in milk, for example. He also succeeded in producing 2 major vaccines through attenuation, which is the process in weakening the organism's strength by passing it successively through animals. One was the anthrax vaccine in 1881, and the other was a rabies vaccine in 1885. And due to this germ theory, that there is also an increasing attention in surgery to the role of microorganisms in infection. Inseparable link to Pasteur in bacteriology, a causal relationship between causative microbe and disease. Koch proposed a postulate, which is a series of conditions that must be met for a microorganism to be considered a cause of disease. So the postulates are written here in the slides, that the microorganism must be found in the organism suffering from the disease, and that it should not be found in healthy organism. Okay, and also that the microorganism must be isolated from a diseased organism and be able to grow in a pure culture. Also, that the inoculation of this extracted microbe into a susceptible host should produce the same disease. And lastly, the same microbe should be able to be extracted from the infected organism and again grown in that culture. So this is Koch's postulate to confirm that the microorganism is the cause of infectious disease. Majorly influenced by Pasteur and Koch, there was then the golden age of microbiology, and in the following decades, there was a discovery boom of pathogens, of infectious agents. Okay, some examples are, for example, leprosy, malaria, typhoid, tuberculosis, diphtheria, so on and so forth. But important contributions in medical science was majorly by the European scientists. Towards the end of the century, there were also other countries were also entering into the field, such as the US and Japan. For example, Dr. Kitasato, who co-discovered plague in 1894, and Dr. Shiga, who discovered dysentery bacillus in 1898. So in the subsequent decades, scientists also started to recognize the importance of vector. In spite of the new knowledge of disease-causing microorganisms, the genesis of many epidemics and the mechanism of transmissions were yet unknown and not clearly understood until the important role of vectors was proposed. The most notable of these transmissions were found to be initially among healthy human carriers. And the second important step was that the identification of carriers of other animal carriers. For example, we could see that mosquitoes were the vectors of yellow fever, dengue, and other examples are as shown here in the in the figure, excuse me. So this discovery of the carrier paved the path for a more effective prevention of disease, even more than the isolation and the understanding of the microbe itself. So due to the discovery and understanding, the mystery of disease specificity was solved, and not the miasma. Okay, and this has led into a more rational prevention and treatment on an unprecedented scale, and marking the major transformation in public health. Among other public health progress in microbiology, discovery of microbiology, Rudolf Virchow was a German pathologist. He was also the father of modern pathology, anthropologist, prehistorian, to name a few. And the most important of all was that he was also credited with the founding of social medicine, here as shown in the slide, as a great social activist who emphasized the need for political solution to health problems. He frequently focused on the fact that disease is never purely biological, but oftenly socially derived and spread. In his well-known statement that medicine is a social science and not, medicine is a social science and politics is nothing else but medicine on a large scale. He also plays an important role in 1848 revolutions in Central and Western Europe, contributing to the promotion of a better living, working and health conditions in 1870s. He had strong appeal for sanitary movement and a devoted politician to develop the modern sewage system in Berlin. To stress that his emphasis on then advances made in this social, economical, and political environment were as much a factor in public health progress as much as the other microbiological discoveries. So listed here are some of the major events of infectious disease in the 20th century. The world wars and the influenza pandemic, discovery of penicillin by Fleming, the health transition or the epidemiological transition, also smallpox eradication, and simultaneously, since the discovery of penicillin, the emergence of antibiotic resistance has been of global concern, and of course the newly emerging and re-emerging infectious diseases. The Spanish flu was yet another devastating pandemic in history. The flu was described as the greatest medical holocaust in human history. In 1918 to 1919, only within the 1 year of this pandemic, it was believed that the flu killed more than the Black Death in the 14th century. That was being transmitted for 5 years. So it was estimated that the flu infected more than 600 million people and caused 50 to 100 million deaths worldwide. The flu itself killed more than the World War. And official records in Japan shows that the death toll of due to Spanish flu was approximately 250,000 people who have died due to the disease. Also, the discovery of antibiotics is worth mentioning as a historical milestone in infectious disease epidemiology. And penicillin was discovered by Hemmings in 1928. Before its introduction, there was no effective treatment to treat infections. And as you can see here, the threat of dying due to an infection was so real and severe during that time. So the photo shows the little girl who was suffering from infections. This was before the penicillin treatment. And a few days later, she seems to have recovered very rapidly. And not soon after the treatment of penicillin, she was completely healed. And this figure shows the crude death rate for infectious disease per 100,000 population in the US in 1900 to 2000. Tremendous public health achievements were made during the last century, and particularly in the field of infectious disease, as shown in the figure. As you may be able to notice here that the mortality statistics fluctuated considerably during the first half of the century, maybe due to a series outbreak of sporadic outbreak of infections. And the outstanding peak, as we have previously discussed, is due to the influenza pandemic in 1918 to 1919. Other science-based medical interventions, such as the antibiotics like penicillin and vaccine, including childhood immunization, have played a significant role in this decline in infectious disease. So also maybe the overall economic growth and that help contributed to less crowded housing, maybe the increased awareness and education, improving working conditions, and better nutrition also contributed to this decline. This achievement in public health is also true in other parts of the world. As shown here in the figure, shows the trend in cumulative cause of death ratios in both sexes in UK here and Japan on the right side of the slide. So as we can see, infectious disease were declining tremendously. And on the other hand, heart diseases and cancer or diseases of the affluent were increasing at a very rapid rate. What is worth noticing is the speed of transition in Japan after the World War due to the commitment and establishment of public health centers, sanitary improvement and vaccination, so on and so forth, have led to this rapid transition, much more than the UK, if you can see here. So as a result, by mid-1960s, experts are now very confident and optimistic that we have conquered the microbes. One example is the statement made by the 10th Surgeon General of the United States, William Stewart, in 1967, stated in the 65th annual meeting of the Association of State and Territorial Health Officers in 1967. That it is now the time has come to close the book on infectious diseases. We have basically wiped out infection in the United States. As we can see from the previous slide, that mortality rates due to infections are declining, are decreasing very rapidly due to achievements in vaccination, sanitation, and so on and so forth. So at that time, his statement may be very logical and in fact very appropriate during that time. And due to the global immunization campaign led by the WHO, smallpox was declared eradicated in 1980. As we have heard throughout this session, it is the disease that was once much of the problem in the past and much feared due to high mortality rates and disfiguring even in the survivors. So the eradication of smallpox was therefore a major triumph of public health. Also, the efforts were taken for polio eradication, also considered as one of the largest global and public health initiatives. The last case of polio in the American region was in Peru in 1991, and in Western Pacific region in Cambodia in 1997, in the European region in Turkey in 1998. So with the novel development of antibiotics, the scientific society had high hopes. As we can see in the previous slide, that experts were now very optimistic that we could overcome the microbes. However, since the mass production of penicillin, there was also almost a simultaneous emergence of penicillin-resistant bacteria. Okay, and then methicillin and cephan antibiotics were also being developed, and simultaneously, not long after that, the resistant bacteria emerged. Until around 1985, almost all antibiotics were becoming impotent, except for maybe, for example, vancomycin. But the vicious cycle seems to continue as vancomycin-resistant bacteria also emerged in later in 1986. So yet maybe partly due to the emergence of antimicrobial resistant, yet nearly 50,000 people were dying every day from infectious disease, as reported by the World Health Report in 1996. And at least 30 new diseases have emerged in the last 20 years, and now together threaten health of hundreds and millions of people. And for many of the diseases, there's still no treatment, no cure, no vaccine. And Dr. Nakajima, I'm sorry, this is a bit too small, who was the Director General of the WHO during the period, stated that we also stand on the brink of the global crisis in infectious diseases, and no country is safe from them. So the over-optimism in the 1960s and 70s were pretty much shattered with the identification of HIV in 1983, which has caused millions of infections. Professor Kihara will actually be talking on the epidemic of the global epidemic of HIV in the, I'm not sure, maybe the next session. But then, since then, the spread of infectious disease epidemic also has affected many parts of the world, along with the wake-up call of the antibiotic resistance, as we have seen in the previous slide. So let's touch a little bit upon the concept of emerging and re-emerging infectious diseases, but I believe Dr. Sugimoto will be discussing in more details maybe in the next lecture. So emerging infectious disease is there are diseases that have not occurred in humans before or have previously occurred but affected only a small number of people in isolated places. On the other hand, re-emerging infectious diseases are those diseases that were once major public health problems globally or in a particular country, but then declined dramatically, and then again becoming a major health problems for a significant proportion of the population. As shown here, these are some examples of the emerging and re-emerging diseases. Newly emerging diseases are shown in red. For example, SARS, E. coli, H5N1 influenza, and the re-emerging diseases are as shown in blue. For example, plague, as we have talked about throughout the course, cholera, and so on and so forth. So we have come to this last slide that I will provide the summary of the class. Also to stress the evolution of the understanding of infectious disease epidemiology. More than 10,000 years ago, humans were basically hunters and gatherers, and there was no epidemic of diseases during those times. Approximately 10,000 years ago, when humans started to learn skills to cultivate crops or to domesticate animals, that might have led into the first zoonoses that marked the major step in infectious disease in humans. Also, with the concentrated dwelling and increase in population with poor living condition, this gave birth to the epidemic, to the propagation of epidemics. Also, to talk about the evolution of the understanding of infectious disease during that time, diseases were believed to have been the result of supernatural punishment and curse from gods or angry spirits. And a few years later, Hippocrates proposed the relationship of diseases to nature. He was the first to propose the observation of the imbalance between man and environment. Also, this influential theory gave rise to the miasma theory. And the next period was the Great Age of Discovery, where there was a globalization of diseases. As we have seen throughout the course, that it has led into the prosperity of infectious diseases. And this was the first phase of germ theory as proposed by Castro, the seed theory. And then the age of enlightenment and scientific discovery, city planning and sanitation, vaccine, and antibiotic discovery has led into the decline of infectious disease. Also, the evolution of understanding, the germ theory has developed much more strengthened into the second phase through epidemiological observation and indirect proof by intervention. And then it was due to Pasteur and Koch that led to the settlement of germ theory, that through their identification of pathogens through his experiment, and also discovery of vectors. And the present days, we are seeing antimicrobial resistance through also the increase in population, development of transportation, and global environmental changes, also emerging and re-emerging infectious diseases have all together led into the prosperity of the infectious disease in the second phase, as in the present day. So this concludes today's class. And if you have questions or concerns, please feel free to contact the course director, which is Professor Kihara, or me, myself, through our emails. And if you have questions, maybe we can discuss after class. If no questions, I would like to wrap up, and thank you very much.